Hi, welcome to another video regarding Smar technology. In this video, we will talk about the position transmitter, TP. The TP is from the famous Smar equipment family. It is an intelligent transmitter for measuring positions. This device allows for measuring linear or rotary movement or displacement. The digital technology and communication utilized by it provides an intuitive interface between the field and control room and comes with various interesting features that significantly lower the costs of installation, operation, and upkeep. The TP employs a magnetic coupling without physical contact to measure position, which is quite fascinating. Therefore, it is immune to effects caused by vibrations, causing better operational durability. The magnetic coupler, as a substitute for mechanical connections, results in a significant reduction in deadband. The TP can be attached to any linear or rotary valve, actuator, or a vast range of other devices, including float damper, height of cakes, grinders, and others. Thus, the primary function of this transmitter is to perform position measurement. What are the existing models available for sale? We have the model TP290, which is 2-wire and works with 4A20. The TP301, which is the 4A20 model and supports hard communication as well. The TP302, which is the foundation field bus. The TP303 model, which is Profibus PA, and the TP400WH, which is wireless hard. So select the technology you want to employ. Here we display all the technologies that are on offer. Regarding the course of action in rotary movements, there is a span from 30 degrees to 120 degrees. For linear motion, we provide a span of 30 degrees to 100 degrees. The installation was directly to the valve or directly to the equipment you want to set up. There are some models of supports available, and with the L-type support, the installation can be done in various positions. And it has internal temperature compensation, meaning the temperature effect does not interfere with measurement. There is an embedded electronic circuit. The feedback without physical contact. The Hall effect sensor outputs a voltage that corresponds to the applied magnetic field. This system is resistant to shaking and mechanical vibrations. An innovative design, the magnet placed in the instrument to be measured, moves according to the instrument's movement. The position sensor, the Hall effect, senses this motion and creates a slight voltage change that corresponds to the magnetic field produced. See here in the figure the Hall attached to the valve's body, and we can detect this position through the Hall sensor. Digital processing makes installation easier It improves how the display is viewed of the value indicating position. Thus, we achieve a simplification of adjustments and an easier way to visualize the position. Certified certification, level of protection, IP66, rated IP68, blast proof and intrinsically secure. IP66 means that the first 6 indicates total dust protection, this initial 6. And the other 6 means it is protected against powerful water jets. And the 8 indicates it is protected from prolonged submersion in water. These are the features of this equipment's protection level. Regarding explosion proof in explosive atmospheres, it is an environment where under atmospheric conditions, air mixes with flammable substances, and after ignition, combustion propagates throughout the unburned mixture. This area requires explosion potential, thus it has these certifications. Regarding intrinsic safety, this is a technique designed to achieve akin to energy levels in electrical equipment circuits at levels such that even in the occurrence of sparking or ignition, the energy available in the spark is not sufficient to cause ignition of an explosive atmosphere. This is the characteristic of intrinsic safety. Here we show a block diagram which includes the main board. Along with the main board, we have the display controller. And here is the sensor board, which contains the Hall sensor magnet and position detection on this sensor board. Here are the parts of the equipment. The electronic enclosure is here. Here is a connection cover and the Hall block. We will talk about these components. So here again, the main board featuring the knob and the display. The connection cover, which connects to the Hall sensor block. The main board or primary housing with the main board. We have the responsibility for management, operation, and diagnostic control. At the back, we have here the need to create the link with the cables here for 4 to 20, or for the digital systems that are available depending on the model. And at the front, we have a cover there with its locks, the screws of the locks, and with the display and the circuit electronic component. So it is also safe from reverse polarity without harm. So up to 35 volts, TP302 and 303 can handle up to 50, 60 volts, while TP301 and 290 can. Watch the power supply to prevent burning your electronic circuit. So we have here the connection cover, where there are 4 screws to fix this cover. This is the sensor's electronic board. We have a flat cable that connects to the main board, This analog board translates Hall voltage into position. This is the Hall effect sensor positioned at the bottom. Inside there is a flat cable and a kind of transistor sensitive to magnetic field changes. Here we show this flat cable leading to the main board, which is actually the analog board. And here the sensor sits on this pin where there is no physical contact. There is no contact, it is done through the magnetic field. So this is noteworthy, because when we have physical contact, we can have measurement errors, and we can have problems with circuits and applications where we have vibration. Here it shows us the Hall sensor. The magnet is polarized. As it moves, it increases or decreases the field. In the center, it has the field neutralized. You connect the magnet to this pin that has the Hall effect transistor. This allows you to easily measure. Here is the magnet. The flat cable with the Hall sensor. Here the rotary is the same. If your application is rotary, there is also the possibility to use this rotary magnet. See the model in the figure. Here are several models, 100 mm, 50 mm, and 30 mm sizes, and the rotary sensor that rotates up to 120 degrees to measure position. So the local adjustments through the holes here on top allow us to make local adjustments. When activated, the simple local adjustment allows you to instantly save the 0% position. If you insert the key into hole Z, and for 100% insert it into S. So you set the position to 0%, put it in Z, set it to 100% and insert it into S for astonishment. The complete adjustment, when activated, allows for changes of the unit that needs to be shown, indicating if it is in reverse or direct mode, to add the upper and lower position values too. Here is the remote Hall, so when you have applications that the sensor with environments with excessive vibration, very high temperature, that exceed 100 degrees. We have there the option to install a remote cable, a remote Hall sensor as illustrated in the figure, which connects to the position transmitter, so we can safeguard this equipment against electromagnetic interference as well as heat. Here it shows where we connect the cable. And with this, we can install this shielded Hall sensor. In terms of assembly, we can utilize an L bracket. It's a bracket that enables us to fix this equipment wherever necessary, whether it is a valve or another device for measuring position. For rotary applications, there is also support for mounting with devices that utilize rotary mounting. So it's also feasible to have this type of support as per Namur, which is the VDI-VDE Namur rotary standard in relation to applications with strokes over 100 millimeters up to 1000 millimeters. This is the BFYCL, this device here. It can boost with this the range for you to measure positions over 100 millimeters. Here we also have a model, it's important to mention, which is the wireless. It is a transmitter via wireless HART digital communication. He is included in this family of HART devices that are made by Smar. For position measurement too, assume you have an application, especially for monitoring. You might not want to use cables, so you can function in a mesh network wirelessly with a reasonable distance between the devices. You can have various communication paths. It has many features. Wireless HART. Once again, it is a technology recognized worldwide, which is the HART technology itself. Very robust, as everyone knows, only with the use of the HART protocol, but wireless. This is wireless HART. In specific applications, we can use the TP400. Here are a few features of wireless HART. We have a HART protocol, version 7, that is quite modern. The battery mode lasts around 3 years. So internally in this cover, we have a battery. It lasts a long time. Local adjustment exists. You can operate without opening the transmitter lid using a magnetic key. It has a digital output using a 2.4 GHz radio frequency. Rotating display which makes reading easier in any position. Its protection degree is IP66 and certification by Anatel, which is still in process. Regarding the applications, one of the important applications. This refers to the movement of the upper roller in the mill. The TP, it is used for you to adjust the distance between the rollers of the mill. It is one of the important applications, the use of the position transmitter. So here's an example. Without local indication here, with it here, it shows us the roller's position. Here showing the supervisory system with its proper indications and its controls too. Controlling the speed of the mill and controlling the position of the rollers. Here is another application featuring sensors. A sensor is present here in sugar and alcohol applications. To find out the mattress height, depending on the height, we can control the conveyor speed as well of the process. Once again, we find ourselves here. The linear displacer, it comes with gates where we can learn by using the BFYCL with a duration exceeding 100 minutes. It can tell if the gate is open or whether the gate is closed. Here too, what we refer to as the touch tube. It's another use, where we have the liquid level of the tube of torque, utilizing buoyancy exercised in displacement. When immersed in a liquid, the buoyancy of the displacer is directly proportional to the liquid level and works in an elastic torque tube, changing the applied force into a rotary motion. It drives the magnet, thus the electronic transmitter operates. So here we have showing us the displace unit, which is an element, a weight that is part of the process. The displace functions with buoyancy. So as the level goes up and down, it can rotate. It has an arm that it rotates. And with that, it can determine the position. There is the magnetic alcohol sensor, the arm, the head, the torso, and the position transmitter, making the electronics to be able to know. In fact, it is a level application. Here is another use. The toasters operating with flour. Flour will be treated and placed. Here's its design. He has 4 to 10 plates. Where we can get it to put the flour in. And then there's the TP. What does it do? It makes adjustments to these distances of the plates. Here's showing the continuity of this application. We have here a palpator, the flour, the dish, and the flour is placed here. And here this guy manages to know the height of the flour. Here's another system showing how it is. This guy actually spins another perspective, and we can do it increasing or decreasing the height of the flour. We can know this level. Here is the assembly of this equipment. Monitoring valves. Wireless heart is being used. Regarding the monitoring of valves, millions of valves exist in the field without feedback. Of position, we have that. Around 300 million valves sold out there. 15% are actuated and 85% are annual. So it's a large field of application. To understand the monitoring of these valves, whether the valves are open or closed, what is the valve's position? So there are few valves that are actually monitored, so there's a large field of action, of application. Regarding the programming, we have it here. The local adjustment via magnetic key. Here's the interface. It's a Bluetooth heart device known as HI333, which you can install on a tablet device. The interface, there is heart or profibus, which is the PBI. Additionally, through computers, working with Pector and Asset View, with FDT-DTM technology. Thanks for tuning in. Check out this new video on Smar technology. In this video, we discuss the temperature transmitter. You can find us here at our website, www.smar.com.br. If you need to request a quote, we have the budget email and contact numbers here. We also provide technical support for any technical inquiries. Contact our support team. Thank you.